Our world operates on a delicate equilibrium, a complex web of interconnected systems we take for granted. This system is not fixed. It only looks that way, a fragile balance, mistaken for permanence. When the balance shifts, the consequences ripple outward, touching every aspect of daily life. Homes heat longer as temperatures drop. Household budgets tighten under the strain of rising energy costs. At the coasts, ports wait for delayed shipments. Grids strain under unprecedented demand. Crops pause their growth cycles, threatening harvests. Flights drift from their usual paths to avoid unpredictable atmospheric conditions. This cascade of effects plays out not over centuries, but within a span of just 5 years. A thin veil rises above the weather, spreading silently where it will stay. At first, the changes are subtle, almost imperceptible. Midway through the period, winds and currents wander from established patterns. Later, global systems of supply, health, and scheduling settle into a new, less predictable pattern. The world still functions, but it functions differently, and it begins now. An immense release of volcanic aerosols, a single cataclysmic event, climbs into the stratosphere and spreads as a nearly invisible veil across the globe. These tiny reflective particles scatter and reflect a small but critical fraction of sunlight back to space before it can warm the ground. The net effect is a modest but persistent global cooling, a planetary fever breaking in reverse. There is no dramatic freeze, just small, accumulating differences, summers that never quite heat up, and winters that linger weeks longer than expected. Daylight itself changes. Light grows diffuse, shadows soften, and familiar blue skies turn a milky, perpetual pale. We have seen this before, in miniature. The eruption of Mount Pinatubo in 1991 cooled Earth by about half a degree Celsius for roughly 2 years. Now, imagine that effect amplified and extended. The veil persists for 5 years, long enough to force deep structural changes in agriculture, energy, trade, and entire ecosystems. A marathon of adaptation begins, not by choice, but by necessity. This Earth, our Earth, will feel colder for 5 years. Before the more severe ground impacts begin to bite, the first signal is almost imperceptible. It's a change not in what you see, but in the very air you look through. High in the stratosphere, a veil of sulfate aerosols forms. This layer is far too fine to be seen as a distinct cloud, but its collective presence becomes unmistakable. It scatters sunlight, washing the sky into a paler, whiter shade of blue, and often edging the sun with a soft, ethereal halo known as a bishop's ring. Direct light behaves differently now. Sharp, defined shadows blur and soften at the edges, as if the entire world were lit by a giant, celestial softbox. This weaker, more diffuse light means less energy reaching the surface. Solar generation declines 5 to 10%, even on days that feel perfectly clear. For households, the reminder appears on monthly statements. It's a small but persistent increase in cost, a quiet tax levied by a changing sky. At noon, the sun's heat on your skin is less intense. Your eyes relax, no longer needing to squint against the glare. The city itself looks quieter, visually calmer. The planet's energy budget shifts. The change is subtle, happening everywhere at once, and it is relentless. Consequences unfold system by system, a cascade of small effects rippling across the globe. Everyone, everywhere, now sees a slightly different sky, a shared but uniquely local phenomenon. A dimmer daytime sun means less midday solar support to the grid, forcing operators to compensate with other, often more expensive, energy sources. The very character of daylight changes. The world loses some of its sharp gleam, replaced by a pervasive, gentle glow. This is the planet's quiet, unambiguous announcement. There will be lower power for the next 5 years. The first impacts are modest, easy to adapt to, but they are only the beginning. The mid-course ones are not. Next, the oceans, which hold the planet's thermal memory, begin to respond. And with the oceans, the calendar itself starts to slip. Cooling is patchy. Continental interiors in the north take deeper, longer winters. First frosts arrive earlier, last frosts linger later. Growing seasons shrink. A week of deep cold becomes 3, then 4. Heat waves peak lower. For many, that eases heat stress and lowers AC demand. Change the equator to pole gradient, and storm tracks migrate. Places expecting spring rains may dry. Others take out-of-season downpours or blizzards. Small shifts in rainfall, 5%, decide normal year or drought. Spring feels delayed. Autumn arrives abruptly. Biological clocks lose their beat. Those closest to the land notice first and change fastest. This is not calendar trivia. It is a reset of seasonal mechanics. Cities adjust behavior at the margins. Layers, timing, routing. Frost lines redraw, planting windows narrow. Longer winters mean longer maintenance, longer fuel use, longer delays, and more decisions under shorter, colder days. Air moves heat. Water stores it. The ocean answers next. Slow to change. Relentless once it does. Surface waters cool over years, not days. But 5 years is enough to matter. With less ocean heat, some major tropical cyclones lose intensity. Cooling alters density contrasts, nudging currents, tempo, and routes. Change the pattern, and upwelling can falter. Plankton blooms thin. Food webs feel the deficit first. Boats return lighter, then near empty. Families and markets follow the numbers. At cruise altitude, the horizon turns permanently pearly. Altered gradients reposition jet streams, the invisible conveyor belts of time and fuel. North America to Europe stretches. Minutes add, tons of fuel tally. Operational costs rise at the margins. Tickets eventually follow. Safety unchanged. Economics adjusted. A quiet chain from high air to deep water and back to shore. When plankton fades, plates change. Systems speak to systems. None stay silent. On land, energy and health adjust to a longer chill. Colder, longer winters dramatically extend heating seasons, pushing electrical grids toward their absolute peaks for sustained periods. The demand for gas, heating oil, and electricity climbs relentlessly, straining generation capacity and translating directly into higher utility bills. Midday solar, weakened by lower sun angles and increased cloud cover, delivers less energy just as demand asks the most of it. Wind helps in some regions, but its inherent intermittency means it cannot be the sole backbone. To prevent blackouts, systems lean heavily on dispatchable power for stability. The cold itself harms directly, increasing cases of hypothermia, frostbite, and respiratory illness. More time spent indoors may ease heat risk, but it also creates ideal conditions for the transmission of seasonal viruses. Yet, there are benefits. Cooler summers significantly reduce the frequency of deadly heat waves, a crucial reprieve for the elderly and those with chronic conditions. And some mosquito-borne diseases slow their spread where temperatures dip below the optimal ranges for breeding and transmission. In commerce, shorter, more volatile growing seasons and storm shifts lift the price of staple foods. Crop insurance pays out more frequently. Inevitably, premiums follow upward for everyone. Financial institutions become more cautious, and credit tightens for all weather-sensitive sectors. Rerouted storms close ports for longer periods. The resulting backlogs can take months to unwind, snarling global trade. These delays and risks mean transport costs add to nearly everything that moves. In response, firms trade just-in-time efficiency for resilience, holding more stock and diversifying with more suppliers. Some exporting nations, facing their own domestic pressures, curb shipments to stabilize their internal supply. What is rational locally becomes disruptive globally. International prices jump, and panic buying follows. Social safety nets must then extend not just for individuals, but under the entire supply chain. This is not collapse. It is a persistent, low-grade stress test on every system we rely on, and a profound lesson in adaptation. Farming converts sunlight, water, and soil into food. Reduce sunlight, shift water, and yields respond. Shrinking growing seasons force ruthless choices. Plant earlier and gamble. One late frost cancels a month of hope. Switch to faster varieties and give up peak yields. Heat-loving crops step back from their poleward gains, temporarily. Pastures grow slower, supplemental feed grows pricier. Plants bloom later, pollinators keep their schedule, and find less waiting. Hatch windows miss, nesting success drops. Cold-tolerant species advance, warm-adapted retreat. Cooler water helps corals, until dim light starves their symbionts. If plankton falters, reefs and fish falter too. After 5 years, the veil sifts down. Each month the blue deepens, light sharpens, output returns. Temperatures rebound fast, the hidden warming reappears. Resilience built under stress proves useful and stays. An unplanned experiment fills terabytes and sharpens forecasts. What scenario should we explore next? Share your ideas below. You've been watching IfVerse, where imagination meets possibility. See you in our next reality.